Hi, welcome to the Penguin Post newspaper by kids. Today we are interviewing Chaitanya. He's a scientist who studies polymers. Let's ask him some questions.
What are you currently learning?
Currently, I'm studying a set of polymers that are called gels, and these are a lot like slime is. And I'm learning new things about the way the material is and how it controls how it behaves. And so I'm very interested in that, and I build microscopes that allow me to look inside these slimy materials to teach me about how they behave so that I can understand them better so that people can be able to use them for a whole bunch of things.
How did you become interested in science and polymers?
So how did is that what you asked me? How did I become interested?
Yeah.
I've always been fascinated by how things work. I know that sounds very general. Like, I really enjoy thinking about and understanding why things behave the way they do. And probably you are too, right? And one of the things that I like about that is coming to a point of understanding where I might be able to help other people use my understanding to improve the things that I am interested in. And specifically, I'm interested in just materials in general. Why are things strong? Why are certain things, why do we use metals to make certain things, and in other places we use plastics, right? So that's what I studied when I went to college. And I became particularly interested in polymers in particular. I'm actually curious, do you guys know what a polymer is?
Sort of.
So what do you know?
I sort of know that it likes to stick to some things.
Okay.
But I think it might have something to do with solids and liquids.
Okay. So polymers are solids, right? And do you know what a plastic is?
Yeah.
Right? So the way plastics are on a very small scale are basically what polymers are. But polymers need not only be plastics like we know, like a plastic cup or something like that. As long as they say they share the same basic characteristics at a very small scale, they could even be materials that make up the human body, for example. The human body is made up of a lot of polymers, right? So let's go back to the question that you were asking me. I said that I'm very interested in understanding things. And in college, I learned about materials in general. And because polymers um, have very simple but fascinating rules about how they behave, I got more and more interested in them. And so the combination of just being interested in understanding how things work so that I can try to make new things out of them so that I can improve people's lives. And also the exposure that I got from working with people at my college while I was learning made me more interested in studying them in particular. Does that answer your question?
How does slime work?
So you guys might actually be better experts at slime than I am in terms of actually working with it, right? So maybe I can ask you a quick question related to that, and then I'll expand on the answer that will more directly answer your question. What can you tell me about slime? What is it?
I would say it's sort of something that you could I don't know, play with when it's more like it has a lot of textures and you can do a lot of things with it, like
Right.
stretch
So
it.
you're saying, so the texture word is an important thing. So Tori and Amelie, what you guys have played with slime, what would you say is different about it? So does it feel soft? Does it feel hard? Is it the way it feels that is different?
It feels really sticky and it's really stretchy.
Right. So it's sticky, stretchy, and the texture is important. And Tori, would you kind of agree with these things? Is there anything that you want to add? Is so you agree? So it's the what is fascinating to you in some sense about slime, which is actually something called a gel, right? So the way when we work with it, we don't call it slime, but it's really the same thing, right? We call them gels, right? So the thing is, sometimes the feeling that you get is because they almost have a capability to flow a little bit, right? So slime is a little bit like a liquid, right? But it feels like a solid, right? It's not as hard as your desk or your computer or something else. It's much softer, but it's got a lot of liquid in it, right? So in certain aspects, slime behaves like a liquid, and certain aspects, slime behaves like a solid. And that's what makes it unique, right? Because it has both these characteristics. And the way you get this is by taking a solid that would normally dissolve in a liquid. So if you took a little bit of sugar and you added it to water, what would happen? So what
Uh,
it'll dissolve, right? You agree? Now imagine, so what's happening to the sugar? All those tiny, like at the smallest scale, the sugar is going into the water, right? So imagine if all the sugar, and I'm going to use a word known, I'm going to call it a molecule, right? And don't worry exactly about exactly what that word is, but think of sugar at the smallest scale, right? And if all the little bits of the sugar, if they were connected in some way, right? So if they were connected and they could not completely separate, right? Imagine if all the sugar molecules or the smallest bits of sugar are all holding hands and refusing to let go. They all want to go into the water and dissolve, but they're also holding each other, right? So what happens is when you take these special polymer molecules that are connected and holding hands, and you put them into something like water, if they like to dissolve in water, they will take on as much water as they can, but they won't completely dissolve because they're holding hands, right? And when I say holding hands, it's just a phrase to allow you to understand. What I'm really saying is that they're connected in some way so that it prevents it from dissolving completely, right? And so slime is basically when you take a polymer that's connected, or you provide a way for the polymer to be connected, and you add it to a liquid in which it wants to dissolve, and it basically takes on a lot of that liquid so that it has properties that are a little like a liquid, but it still feels like a solid because the polymer molecules are connected or holding hands. Does that make at least a little sense?
yeah.
Right? So one last thing to connect to how you guys play with slime. When you make slime, what do you do? So anybody who wants to, who's the person who's played with slime the most recently? Who's made it the most recently? So Carmen, what do you do when you make slime? Do you take Elmer's glue?
Yeah.
And what else do you, so that's your polymer, right? It's a particular polymer, it's got a particular characteristic. And what do you add to it?
The borax.
Right. And so the borax actually is the thing that makes the Elmer's glue hold hands between the molecules. It's the thing that connects all those molecules. So now when you add water that's already present in the glue to some extent, it forms slime. And it behaves a little like a liquid and a little like a solid. And that's why it's unusual and feels a little special because it feels squishy, but it doesn't flow and wet stuff exactly like a liquid, but it still feels a little sticky. Does that make sense?
Yeah.
That's sort of how slime works. There's of course a lot of other details, and I spend a lot of time trying to figure out those details, and that's fun.
What is your favorite part of your job?
So, as part of my job, I do multiple things. I'm a scientist. I'm also a teacher. I teach students about the things that I've learned and the things that I'm continuously learning. So I think the two things that I like the most, if I'm allowed to pick two favorites, is that I enjoy learning and understanding the way things work. So if it's slime or if it's a gel and it behaves in a particular way, I want to know why is it that it does that. And that when I start to understand something, that realization, that moment of recognizing, oh, this is why it does that, that moment is something that I value a lot. So I enjoy understanding things, and I really enjoy the moment of coming to realize why things work the way they do. And the second thing that I really like doing is I like sharing that understanding with people, right? So that's why I'm also a teacher. I like sharing that understanding with other people who also want to understand why things work the way they do, and in particular, the things that I have come to work with and understand. And that moment when I can communicate to somebody else who's interested in what I am interested in, that moment when they also understand that what I understand is something that I really enjoy. So those two things, understanding how things work and then communicating that understanding and sharing that joy of that insight that you get, is something that I really like. So those are my favorite things about what I do.
Were you very interested in polymers when you were a kid?
As a kid, I didn't recognize, as a kid, I didn't have that exposure to understand what polymers were. So you guys are like way ahead of like where I was as a kid, right? And like the things that you're doing, like with this penguin post and the other things, are actually extremely impressive for me. So as a kid, I wasn't aware really of polymers in the way that I am now, but I did have a curiosity, and the primary thing that I mentioned earlier of being motivated by wanting to know why things work the way they do is something that I had at that point. And as I grew older and I started um, going to school and learning about materials, I became more interested in them, particularly because I felt that understanding them would allow me to have an impact on other people's lives. And so, although I didn't know about polymers when I was a child, I did have a curiosity about trying to understand how things worked, and just an interest in knowing that if I understood something, that other people might be able to benefit from that understanding.
Why do you think slime changes its texture when you keep mixing?
So, the properties of how slime behaves can depend very strongly on what you're putting into it, right? So, one of the aspects of slime is that it's made up of polymer molecules, right? And the slime that you are talking about in particular, right? When it's holding hands, it's got a particular manner by which the molecules stay connected, right? So when you are constantly, what was the word that you used? That the texture changes when you knead it? Is that what you're saying? Mm-hmm. Right? So as you are working the slime, you are affecting the connections between the molecules. In the initial stage of when you're kneading it, right, the connections tend to be stronger. And so it can feel slightly different and it can feel a little more stretchy, right? And when you give it more time and as you move it and work it, the connections have chances to move around and release and things like that. So sometimes you might find that, like you said, the feel of it changes because of the way the the polymer is connected on the small scale changes with time, right? So whether you can stretch it or whether it is easier to pull apart will change as you are working the material, and the manner in which the things are connected will be affected as you are working the material. Does that sort of answer your question? All right. That's a very interesting question. Have you ever played with something known as silly putty?
Yeah.
So if you take a ball of silly putty and you roll it up, right, and you make it a ball and you drop it, will it bounce or go splat?
Down?
So it'll bounce, right? Try it. It'll bounce. But then you can take that same ball, right, and you can leave it on the table and leave it for 20 minutes, right, and come back and you'll see it's not a ball anymore. It's kind of smooshed out, right? And so the same thing that makes it bouncy in one case, and the same thing then smooshes out if you give it enough time, is the same basic set of ways that slime is working, that when you're playing with it, it feels like the texture is changing. And it's got to do with how connections change with time.
What makes slime stick to itself, not your hands?
So I'm not sure I have a good answer to that question fully. So this has to do with why things stick in the first place, right? Certain things like to stick to themselves, and certain other things like to connect to other things. And we call this bonding. And it depends on the specific aspects of what the materials are that you're considering, right? And in the specific case of slime, it happens to be a slime and your hand. It happens to be that the material prefers to stick to itself rather than to stick onto your hand. So when you make a new surface, because there is liquid and because of the nature of what we call bonding, and I'm effectively giving you a word that is hiding a lot of the actual things of what is happening. But the idea is that the material prefers, like you said, to stick to itself rather than to attach to your hand. And that is just related to how what the molecules like to surround themselves with. So certain molecules like to surround themselves with each other, and that's where they are happiest. And other molecules, depending on what state they're in, like hydrogen likes to react with oxygen to make water. Now, maybe some of you guys may have heard of these particular chemicals, but in certain situations, chemicals like to connect with each other. And in other situations, they like to surround themselves with just themselves. And when you make slime, it's in a state where it likes to surround itself by the same material. And so, although it feels slightly sticky when you knead it around, it doesn't stick to your hand permanently.
What is one of your biggest goals that you have achieved?
What is one of the biggest goals that I have achieved? Okay. That is an interesting question, and something that maybe I should have spent a little more time thinking about. So, I'd say one of the biggest goals that I have achieved is answering, is learning how to do things and learn things, learning how to teach myself about how things work is something that I think is one of the biggest things I've been able to do, is learning how to teach myself how to understand how things work. And I'm not saying that I know how everything works. That's definitely not the case. But I have gone through the process of trying to understand new things enough times that I think I've gotten kind of good at it. And it's something that even if I don't know if I'm necessarily proud of it, but it's certainly something that gives me a lot of joy and satisfaction.
That was so cool. We learned a lot from you, and thank you from your time. Bye.
Bye. Thank you very much.